Question 12, calculate the weight of an ice cube that has a volume. So weight is equal to mass times gravity. We've got the density of the ice cube. So mass, we do not have anywhere here in this information, but we have density. We know that we can expand mass into density times by volume. So we have the density of the ice. The weight is what we're trying to find out. We've got the volume of the ice, which is there. It's in standard units, no conversions required. And G is 9.81. So 920 times by 4 times 10 to the minus 6 multiplied by 9.81. We get a weight of 0.036 and its newtons. Weight is measured in newtons. So 0.036 newtons. Part B, it says we have an ice cube. The diagram shows an ice cube floating in a beaker of water. When the ice cube is placed in the beaker, it displaces volume of water, causing the water level to rise. So what's happening? The reason why the ice cube is floating is because there's an upthrust on there, and the weight of the water displaced is equal to the weight of the ice cube. The weight of the water displaced is actually the upthrust as well. So we're going to use this statement to answer the question. If this statement was not there, we know that the upthrust is equal to the weight of the water displaced as well. Okay, so here we've got the statement: the weight of the water displaced is equal to the weight of the ice cube. The weight of the ice cube. Okay, so we've got the weight of the ice cube, which is here. The weight of the ice cube. That's the same ice cube. Nothing's changed. Okay, so we don't really need to expand this out to density times volume times by gravity as we've done there, because we've already got the answer of 0.036 newtons. So that's why I've not really expanded that out. So the density of water times by the volume of water is equal to the mass of water, and we know that the weight is equal to mass times gravity. So there's your mass and times by gravity. So the density of the water is there. Density of the water, we've got that number. We're trying to find out the volume of water. So this is our unknown. A gravitational constant 9.81, so that we know, and the weight of the ice we know from the previous section. So the only unknown is the weight of the water. So I rearrange, and the weight of the ice cube is 0.036 newtons. The density of the water is 1000 times by 9.81, and that is 3.68 times 10 to the minus 6 meters cubed. Okay, so we know that the forces are balanced and the weight of the water displaced is equal to the weight of the ice. That there is the big hint, and that's where we start. And then when we expand out, we get to this point and our answer there.